Okay, my Q2 students, this right here is for you guys. If you are watching this to get help on your homework, be sure you leave a comment down below. Just say hi, and also don't forget to give me a like. You guys know the deal because I taught you guys how to do it today, right? Anyway, first we are going to verify that this right here, it's the general solution to this differential equation. And notice that we have the C1 and C2, two constants. And the reason is because we have a second order, because we have the second derivative right here, right? Second order differential equation. But as usual, we'll just go ahead and look at the function y is equal to C1 e to the negative 4x plus C2 e to the 2x. Differentiate, and then plug in, right? So here we go, y prime. This is a constant, and when you have e to the something, you first keep this, so write down C1 e to the negative 4x, and then multiply by the derivative of this. The derivative of negative 4x is just negative 4. And then you add it with, you keep this again. So you put C2 e to the 2x, and you multiply by the derivative of that, which is a 2, like that. And then you continue. Let's do another one. Y double prime. First you keep this, but you know you have to multiply this with negative 4, the derivative of negative 4x. So negative 4 times negative 4, you will end up with positive 16. And then C1 e to the negative 4x. Similarly, you do 2 times 2, which is 4, and then C2 e to the 2x. And now we have all the ingredients. We just have to do the check now, right? So part A, we are going to check, and all we have to do is plug in. So here we go. This right here is the second derivative. I'll just put this here, which is 16c1 e to the negative 4x plus 4c2 e to the 2x. And then we are going to add 2 times y prime, which is that. So you just put down negative 4c1 e to the negative 4x plus 2c2 e to the 2x. And lastly, we also have to do minus 8 times y, which is the original. I will just put down c1 e to the negative 4x plus c2 e to the 2x, like this. And do we end up with 0? I don't know yet, but I will show you it will be, right? So let's do a few things right here. Of course, if you do this times that, you get negative 8, and then c1 e to the negative 4x. And then when you do this times that, of course, you end up with plus 4 c2 e to the 2x, like that. Same thing here, you do this times that, which you will end up with negative 8 c1 e to the negative 4x. And then lastly, this times that, you get negative 8 c2 e to the 2x, like all this. Well, check this out. Here we have 16c1 e to the negative 4x minus ac1, all that. So this can be cancelled with that, can be cancelled with that, huh? Very cool. And then better yet, take a look. We have 4c2 e to the 2x plus 4c2 e to the 2x, which is 8c2 e to the 2x. And then we have the minus ac2 e to the 2x. Of course, this can be cancelled with this, and that. Therefore, all in all, you do end up with 0 being equal to 0. So checks. That's for part A. Now, once you know this right here is the general solution, when we have two conditions which were given this and that, we will be able to solve for C1 and C2. So for part B, this is what we have to do. When we have y of 0 is equal to 2, let me just write this down right here again. Y of 0 equals 2. This means x is equal to 0. The y value will be 2. Well, look back to the general form right here, or here up to you. You just have to put 0 into all the x, and then you will get C1 and C2. You'll see. So 2 is equal to the following. Remember, this is the y value, which is 2 already. Let me just write it down. Y is 2. And I will put 0 into the x and here, and we get C1 e to the negative 4 times 0 plus C2 e to the 2x, which is again x being 0, like that. And check this out. C1 times this, 0 times this is just 0, which is just e to 0, which is 1. So you have C1 plus C2 is equal to 2. So you have the first equation. So I'll write it down right here. We know C1 plus C2 has to be equal to 2. Well, we don't know what C1, what C2 is. It's okay because we'll have another condition. We'll come with a system of equations. Here we go. Y prime of 0. Right here, y prime of 0 is equal to 3. So we will be utilizing this right here, right? When x is 0, y prime will be 3. So I'll just have to put 0 into this x and that x now. And let's take a look. We will get negative 4 c1 e to the negative 4 times 0. And then we add 2 c2 e to the 2 times 0, like that. And of course, from here, earlier we got c1 plus c2 is equal to 2 from the first equation. And for the second equation, we have this plus that is equal to 3. So I will write down negative 4 c1 plus 2 c2 is equal to 3. So we end up with a system of equations. Depends on how you want to solve it. I would recommend you guys to do elimination. Let's multiply everybody on the top equation by 4. So we will end up with the following. On the top, we get 4c1 plus 4c2 equals 8, 4 times 2, right? And then this right here, minus 4c1 plus 2c2, it's equal to 3. All right, here, of course, you add them up. This and that will be gone. And then you have this, which is 6. C2 equals 11. Divide both sides by 6. C2 is equal to 11. Since C2 is equal to 11, we know C1 plus C2 is equal to 2. So I'll put this right here. We know C1 plus, 11 over 6. 11 over 6. C2 is 11 over 6. This is equal to 2. And of course, minus 11 over 6 on both sides. So this is like 12 over 6. Do your fractions. C1 is equal to 1 over 6, like that. So we got a C1 and C2 right here. And in the end, we can present the equation to the differential equation with these initial conditions. So I will write it down right here for you guys. So the final answer, if you put C1 and C2 together back into that, C1 is 1 over 6. So we have y as a function of x. And if you just put on y, it's okay. I won't be mad at you. Y of x is equal to 1 over 6 times e to the negative 4x plus C2 is 11 over 6 times e to the positive 2x. Just writing. And here you have it. This right here is your solution to this differential equation with the initial conditions. And that's it.